How my research started is in a simple problem. It's asking if you have a line, probably a vertical line, and you have a set of points. You want to find the point on that line that reduces the sum of the distances to the other points. I soon noticed that the x-axis based regression was a highly effective statistics tool, though it wasn't truly optimized. So I created a weighted regression where I added weights to certain variables. I did this by using statistical tools like measuring variance, or using Euler's method to match the variance of the predicted dataset to the actual dataset. So basically how an x-axis based regression that is weighted works is it says, okay, we have a set of data points, and we're trying to find a point on, let's say, x equals 3 that best represents the dataset. In order to do this, we have to look at the points nearby in order to find the most reasonable estimate. So if we look at x equals 3, we can see points around that. And therefore, we can make a weighted average based on how close these points are. So the closest points are weighted more than the farther points, and in turn we get a weighted average that is a pretty good estimate. This, similar to how a regression works, instead of trying to draw a best fit line or curve, it solves for each point individually. But in turn, if you do a whole bunch of points, then you can also create a best fit line. So it originated on a vacation in Germany, and I really just thought of a lot of problems in the car for me to solve. However, there was one problem that was ridiculously hard. I couldn't even get close to thinking of a solution. I tried doing all the simple things you can do. Simply solving it through algebra, taking the squares of the different terms in the summation, and also I tried taking the derivative. I did all sorts of things in the car. However, found it incredibly hard to solve and didn't even have a clue how to solve it. I tried using average and tried doing all sorts of other things. So I did some research, and when I got back home, I started asking people around me on if they had any ideas on how to solve it. Since I was stuck by myself, I asked my brother, who's a high school calculus student. We worked a long time together on it, and we couldn't find any solution at all. So I had to find someone who knew a lot about math. So I went to my advisor, Mr. Ordonez, but I also took it to him, and he recommended squaring the terms. I thought this was a pretty good idea. However, after putting in my computer, I found that it really didn't work. When you square the terms, you make all sorts of assumptions that simply don't always work. So then I went to the head of the high school math department. He gave me the same answer, and I needed to find someone who was a real expert in the field. So I reached out to a professor named Spiros. He's a quantum physicist at Caltech. He quickly became highly engaged with the problem. I started meeting with him weekly for a few months. However, even me and Spiros were unable to find any really good solutions. We started by reflecting the points of the lines and doing all sorts of simple tricks. However, we couldn't get anywhere. We started trying to do simple cases, but even with 3 points, it became incredibly hard. So we started to do some research to see if it was even possible. We found one person who said that it expanded out into a 6th-degree polynomial. After doing the math a few times, we found this was correct. Though, this doesn't necessarily mean that there's no non-analytical solution. So we started trying to use tricks. We started trying to use all sorts of symmetries in the problem. However, even that didn't work. We tried for a few months and were unable to find anything, meeting every week. After becoming frustrated with this problem, I continued trying to work on it, but to no avail. But there was one thing that did come out of it. I noticed that it was a really effective statistics tool and started to work on it more and more. After this, I started to meet with one of my family friends, Preston. He was an economist at Microsoft and also a statistician. So I originally developed some techniques that was really effective. But on top of that, Preston also helped me further optimize those to make them even better. So after creating this optimized regression, I ran it on some applicable datasets and found that it was very, very accurate, better than any other regression currently out there. How can my x-axis based regression be applied? Let's use this simple example of trying to predict the optimal minimum wage. So how can we do this? First, we need to give a weight, or say what is actually the optimal minimum wage. We can define this by saying whatever minimum wage that maximizes the GDP per capita. What my x-axis based regression can do is find a connection between minimum wage and GDP per capita. Given a federal minimum wage, my x-axis based regression will output a GDP per capita. Given this, it is quite simple to find the optimal minimum wage. This is just one example on how my x-axis based regression can be used. But it can also be used in other cases, like economics, trying to predict future stock values, or medicine, when you're trying to predict how much medicine someone should take, and a list of other things that have a lot of significance. Furthermore, I think it could impact our world in all sorts of positive ways. If we're able to predict the future, we can make more informed decisions, and we, in turn, can make a better world for everyone.